Okay, hello AskPro community. We continue to interview our experts to suggest you a deeper dive into their background and adopt some tips they share in the video. And today our guest is Alin, a machine learning engineer of 6 years, specialized in general machine learning and natural language processing. Hi, how are you
Hi,
doing?
hi. Thank you for having me. I'm
Thank
really
you for
good.
coming.
Thanks. Um,
Yeah, let's maybe start into a data trip on your day-to-day job so everybody understands exactly what your responsibilities include. And I'm gonna go through like some points I understood, like being not in direct contact ever with ML engineers. I've never worked with you guys directly, but yeah, have some understanding. So first of all, probably as any engineer, you try to translate like a real world issue business brought into a technical task ML can solve. And after that, you deal with data. So I'm interested in whether you gather it or you draw some requirements, define some requirements, and how do you like clean or normalize it afterward.
yeah, sure. Exactly. So everything starts with a business problem. That's what we are trying to solve. So the first step would be actually identifying the business problem, and this can come from both sides. You can have the business come to you and try to solve a problem, and you make them understand if that's something you can solve through machine learning AI, or you can actively participate in their day-to-day activities and spot things that can be optimized, automated, or enhanced through machine learning or AI. And once this step is done, and you can clearly say we have this business problem and we can solve it using machine learning AI. Yep, the next natural step would be, is there any data to support this problem and the solution? Because machine learning is all about having data around that problem to utilize.
Mm-hmm.
Um, so that this is the second most important point. And if you are in the happy case where the answer is yes, we have some at least semi-structured data that we can use to solve this problem. This is where the actual process begins, and there is an initial analysis phase, like what type of algorithms should work here, what type of task is this,
Mm-hmm.
um, and so on. And then the actual implementation comes, and you say, I have this problem, I have this data, I have this plan. Now I'm gonna actually start and identify the data sources for this data, pull this data where I need it to be, clean it, prepare it, do feature engineering, so transforming the
Mm-hmm.
raw data in machine specific data for each specific algorithm. Depending on the type of algorithm, do training if it involves that, and in the end, get the final result and integrate that final result with the rest of the systems that you have in your business. And
Mm-hmm.
that's,
Mm-hmm.
I think, would be a pretty complete chain of action for machine learning.
Okay. Yeah, thank you. Pretty clear. Well, when it comes to like data preparation and working with data in general, is it more manual process or some stages of it are automated?
So, uh, you'll see a recurring theme from me saying throughout this talk of ours, uh, that everything will be very dependent on the problem and on the data. So
Yeah.
when we talk about tabular data, so tables, clearly you can have some process in place related to the ETL process, extract, transform, and load process, which checks data for certain quality measures and so on, and pulls just things that are above these thresholds. But there will always be manual processing involved in analyzing the data, because AI machine learning, it's not just about applying the algorithms or knowing what to apply. It's also, as you said, closely related to data processing, statistics, and so on. And it's always good to have a hands-on approach on the data, since that's the key of everything. And yes, there are manual processes involved in checking the quality of the data, checking for missing values, checking distributions, and things like this. For
Mm-hmm.
text, it's then another problem because you can have different characters replaced by symbols. So A with ats, trees replaced by with e's, and so on, or the either way around. S's with dollars, and again you have to check the data set, see what type of noise, what we call, so what
Mm-hmm.
type of dirty data you have and how you can clean that. And usually things are pretty known, and it doesn't take a lot of time to implement the actual solution to clean this data. It takes more time to analyze the data, and that's, yeah,
Mm-hmm.
a manual process, and it should be probably a manual process to be sure you did a good job in this critical step of the project.
Mm-hmm. Mm-hmm. So it sounds like a lot of work to me. I have trouble with these routine tasks. But what if you missed something? Do you see do you have a mean to check whether it's clean and ready, and or you see the troubles in the solution itself, and you guess that probably we didn't standardize it enough?
um, yes, the problems can appear at multiple steps. So the first step where you can see the problem is when you actually feed the data into the algorithm, because then if some data was not prepared in the way the model expects that data to be, you run into problems and errors. That's the happy case. The not so happy case is when you have your data prepared from a numerical point of view, and the model accepts that data and uses that data to do a task, but then the performance of the task is not great because
Mm-hmm.
maybe you transform that data in a not so representative way, or
Mm-hmm.
you didn't enhance the data enough, or you didn't identify that probably that data won't be enough to solve the problem in the first place. And you have the data, you have the model, it gives an output, it resolves to some extent your task, uh, but the performance is not great. So here it's another entire subdomain identifying what went wrong.
Mm-hmm.
Um, and yeah, that's also very important. And again, very task specific, because you have different error measures. You obviously need to include business information. So what was from a business perspective expected from the algorithm and what's not happening. You have to leverage all this information to identify not just the numbers in the error function, uh, if your algorithm is truly performing what it should be perform.
So you're also responsible for maintenance and monitoring. You probably have different metrics to to watch whether something is not function the way it's supposed to.
Yes, it's by default part of developing this type of algorithms. You have to make sure that the result is the desired one. You have metrics to evaluate that. You have also ongoing monitoring. So some algorithms and some problems in the world can suffer from what's called concept drift. So if I
Mm-hmm.
have an algorithm that consumes data, real-time data, after some time that data changes distribution, changes tendencies, and the specific algorithm, it's especially if it's supervised, so you have a training process, probably won't be able to generalize this good and be relevant for many years in a row. And you can monitor if there was such a concept drift in the data you use, and if the model degraded in performance, and then you do a retraining. You can do multiple things. So yes, in a nutshell, um, the responsibility would be to um, take care of the entire process from
Mm-hmm.
problem up to you are up in production and safe from all these statistical dangers, let's say.
Mm-hmm, mm-hmm.